Right, we're doing it. It's time. Math. Well, this is a series I'm going to call Things That I Wish my general math students would remember. So, we'll take it right back to algebra. Oh my goodness, people ask me, why do we study algebra? Like, what's the deal with algebra? Well, the deal with algebra is we want you to make money. But you might be wondering, how does this relate to actually making money? Well, you know who makes money besides teachers? Tradespeople. Do you know how they make money? So let's say, for example, you have a broken or like a bust tap, right? And you need it fixed, and you don't know how to fix that, right? So you call a plumber. So did you know that when the plumber rocks up to your place, even without doing anything, he's charging you money already? That's called call-out fee. So that's how they make the money, right? So they charge you a call-out fee, and then they work for a bunch of hours for whatever rate, and then they bill you that, and that's how they make a buttload of money. But let's see how algebra actually works out for that. Right, so it looks a little bit like this. Let's call this call-out fee over here. Call-out fee. Let's see, he charges you, I don't know, $100 just for rocking up there. And then his hourly rate, let's say he charges you, I don't know, $30 per hour. And then after that, he says the job is gonna take, I don't know, 3 hours. Like, straight away, you already know from here how much he's gonna make for that job, right? Because he is going to make $100 from his call-out fee. He's going to work for 3 hours at a rate of $30 an hour. So it's really the amount of money that he makes is his call-out fee plus 3 lots of his hourly rate, which then brings you to $190. Cha-chinga. How does that look like with algebra? Well, it looks a bit like this. So we can say that his money that he's gonna earn is his call-out fee plus whatever rate that he's charging times however many hours that he's gonna be working, right? So if we use this in traditional algebra, instead of using that dollar sign, we normally use y for something that results, right? Equals to where we're starting, his call-out fee, we'll call this C, where he starts, plus mx. Well, in some places, we really see this as y equals to mx plus c. Right, I can already hear you in the comments. You're like, wait, hold up. How do we go from money to letters? This is where like everything is confusing. I understood money, but letters, what the heck? Let me show you how and why. So, fresh page. Y equals to mx plus c. Whatever you've learned in high school about algebra is going to bring you to this exact moment. So, what on earth is this right here? This tells me that there exists a relationship between two variables, x and y. Okay, so what this y equals mx plus c business is that it tells me that I can model what's known as a linear relationship between any two things. Okay, so what I mean by that, in the tradie, right, we would expect that the more he works, the more money is going to be paid, correct? So we kind of almost want to see something like that going up, because it just makes sense, right? The more money, the more hours that you work, the more you get paid, okay? But how do we model this? Well, we use letters to help us with that, okay? So this right here, this dollar bit over here, well, we put that on the vertical axis over here, and it's a reason why We put it in that vertical axis over there. We call this the response variable. Okay, because that is responding to time. And we're going to call this our explanatory variable. Because it's the amount of time that he works. Well, the amount of money responds to the amount of time that he works, okay? So, ignoring this little bit of here because you can't really can't go back in time. So, we'll say that he starts off right here, right? And for every hour that he works, he's gonna make a certain amount of money, right? We discovered that at the start, our tradie is making $100 just for being there. So really, he starts off at $100, right? And it seems to me that every hour that he works, he's gonna make $30 more. So he should be sitting at 130, 160, 190, 210. Okay, so that is this relationship between two variables using letters, and that's why we learn a bit of algebra, just so that we can model any relationship that exists between two variables. And that's how you do it. Explanatory variable. Because it's the amount of time that he works. Well, the amount of money responds to the amount of time that he works, okay? So, ignoring this little bit of here because you can't really can't go back in time. So, we'll say that he starts off right here, right? And for every hour that he works, he's gonna make a certain amount of money, right? We discovered that at the start, our tradie is making $100 just for being there. So really, he starts off at $100, right? And it seems to me that every hour that he works, he's gonna make $30 more. So he should be sitting at 130, 160, 190, 210. Okay, so that is this relationship between two variables using letters, and that's why we learn a bit of algebra, just so that we can model any relationship that exists between two variables. And that's how you do it. But you might be wondering, wait, why on earth is this useful? Well, let's have a look at putting together our little linear equation, if you may, that relates the amount of hours that this tradie works and the amount of money that he earns. So, we've established that for every hour that he works, he gets paid $30 an hour, right? And we've already established that his call-out fee is $100 flat, okay? And we've also, used other symbols, and we've said that the amount of money that he's earning really is his rate times the number of hours that he's worked plus his call-out fee. That's a little kind of similar to what we did just now. Y equals to mx plus c. Okay, so over here we've got our response variable, our money, and then we have our explanatory variable. And yes, you are wondering what M refers to. M refers to this rate. Rate of what, you might ask? This rate, we also have another name, we call this the rate of change, also known as your gradient. And what on earth is this C business over here? This refers to, well, I affectionately call it where we begin. But the proper term would be the y-intercept. The mathsy words for you. It just means where the amount of money at hour 0. Okay? And that's our little model over here. So putting the numbers, well, the real life numbers into this little model over here, I could say that his however much he's making, y, equals to his hourly rate of $30 times however many hours that he's worked. So instead of using hours, we're going to use x for that. 30 multiplied by x plus his call-out fee, and we know that that's $100, 100. So this linear model of this little tradie over here would be y equals to 30 lots of x plus 100. And there you go. Our first linear model showing you the relationship between the hours of time that the tradie works and how much money he's making. Well, now you're wondering to yourself, okay, we've got a bunch of letters, a bunch of numbers that models a real life scenario, but where am I going to use that in real life? Well, let me show you. So let's say we've got our plumber model over here. His y equals to 30x plus 100 up here just for reference. Okay, so let's say you've got a scenario where this plumber has gone and quoted, maybe, I don't know, this retiree for a particular job, and he says that, yep, this is my call-out fee, and yep, this is gonna take 5 hours, and this is gonna be so much money over here. But then the retiree goes, well, sir, I am retired and I don't have that much money. I can only afford to pay you $400 is all that I can pay. Can you work something out for me? Well, looking at this linear model over here, he already knows that he needs to work 5 hours for that job. That's non-negotiable, right? So he's got to figure out, how can I make this work? Well, looks like I've just shot myself in the foot here, because if I did the quick maths over here, I think that would really fit her budget. So let's say instead of $400 her budget, let's say she can only really afford to pay him $150 as a budget, right? Okay, so we know that his hourly rate is still going to be $30, right? But is there some adjustment that he can make? Right, let's have a look here. So the maximum that she can pay is $150. We know that his rate is really $30 an hour, and it's a 5-hour job. 30 times 5 plus a certain amount of money over here that we could probably wheel around. So 150 is the amount that she can pay. $30 per hour for a 5-hour job is 150. Well, it looks like he will have to give her the call-out fee. Well, another situation would be, let's say he's got a big boss, right? And the big boss says, well, looks like I reckon you are an incredible plumber and you're gonna make me a whole lot of cash, and I want you to make me $1,000 today. Otherwise, you are fired. Well, can you do it in one job? I don't know. Let's see whether we can do that. So coming back to our little linear model over here, y equals to 30x plus 100, assuming he just goes to one house. Well, he needs to make $1,000 somehow from this one job, and he's only going to charge $30 per hour with his call-out fee over here. So let's see how many hours this plumber needs to work. Well, so taking out his call out fee, let's get rid of this on the right hand side. But I know that if I get rid of something on the right hand side of an equation, I gotta get rid of that on the left hand side as well, right? Because it's a balance equation. So I've got 900 bucks over here on the left equals to $30 per hour times however many hours that he needs to work. Well, if he's gonna charge 30 bucks an hour, I gotta figure out how many hours multiplied by 30 gets me to 900. Well, to do that, all I need to do is just divide both sides by 30 because that cancels out, cancels. Wow, it looks like this brother over here needs to work a grand total of 30 hours just to make ends meet. Now you might be thinking to yourself, man, this plumber is stupid. Like, there's no way a job's gonna take him 30 hours to do. Surely not. Surely there's another way to make $1,000. Well, you are correct. There is a way to make $1,000, not just from one job, but from multiple jobs. Well, let's see how that might work over here. Still using the power of our linear model. Y equals to 30x plus 100. Okay, so let's say brother is capped at, I don't know, union hours. So he needs to make this 1,000, right? Maybe he can only work a maximum of, I don't know, 5 hours per job or something like that, right? So let's go 5 hours per job maximum, right? So he's got to figure out how many jobs does it take for him to make $1,000 if he can only work 5 hours per job. Well, using our linear model, $1,000 is what he needs to make. He can only work 5 hours per job. So let's go ahead and put 30 times 5 over here as his little hourly comp plus his call out fee per job. And let's put that as his cost per job. And we need to figure out, let's go J for job. So job times this amount of money per job. Let's see how many jobs brother needs to do to make this $1,000. Okay, so we've got $1,000 over here. J, number of jobs. 30 times 5 is 150 plus 100. So for every job that he's going to work at, he is really going to be earning $250, right? Okay, so we got $1,000 that he needs to earn. So we need to figure out how many number of jobs times 250 gets me to 1,000. So to suss out this number of jobs, I'm going to divide both sides by 250. That cancels, and I know that 4 lots of 250 make up 1,000. So, ta-da! Brother needs to work 4 jobs to make $1,000. And that's a happy camper right there. And this is the power of a linear model. Ta-da!